Imagine this: a cold, dark silence stretched across the solar system, broken only by the faint hum of machines listening. Every telescope, every sensor on Earth and in orbit was turned toward a single, fleeting point of light. 3I Atlas, an interstellar visitor sweeping toward its perihelion. It was supposed to be a simple observation, the most predictable event of the year. But then, something extraordinary happened. When the data arrived, it didn't show the usual smooth brightening of a comet nearing the Sunday. Instead, it pulsed regularly, rhythmically, like a heartbeat echoing through space. And that's when the question arose, one that has haunted astronomers ever since. Is the universe merely playing tricks on us? Or is something or someone modulating that light? You see, that's the beauty and terror of discovery. When the familiar begins to whisper something new, something slightly and deliberate. The data became a kind of Morse code, a steady rhythm that no natural comet should produce. And yet, every observatory across the planet measured the same pulse, down to the fraction of a second. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So, let's continue. The first light curve of 3I Atlas appeared on a cold January morning, and for a brief moment, it looked exactly as we expected. The comet brightened as it approached the sun, a smooth, graceful rise in luminosity, a celestial heartbeat of melting ice and dust. But as the hours passed, something impossible began to emerge from the noise. The light didn't fluctuate chaotically, as comets usually do when jets of gas burst and fade. It pulsed. 3 perfect peaks, evenly spaced, each separated by precisely the same interval of time. At first, most teams thought it was a calibration fault. Some blamed cosmic rays, others suspected software. Yet as the data flowed in from Chile, from Mauna Kea, from the European stations in La Palma, and the cold deserts of Atacama, every telescope showed the same rhythm, identical. In phase. You see, that's not how nature usually works. Comets are messy, unpredictable creatures. They tumble and spew gas in chaotic directions. Their light is a flicker, not a metronome. But 3I Atlas was different. Its light was modulated, controlled, somehow, as if it were responding to an invisible signal. It was as though the universe had chosen to play us a note, repeating it again and again, daring us to listen closely enough to understand. When the first joint conference was called, I remember the hush that filled the auditorium. Rows of scientists staring at the same graph projected onto the wall, 3 luminous peaks, each one clean, crisp, undeniable. You could hear people whispering, "It can't be real," and yet, there it was. Instruments that had never been connected before were now united by a common heartbeat from an object billions of kilometers away. It was the first time in decades that astronomy felt less like measurement and more like mystery. Perhaps, I suppose, this was how ancient observers once felt standing beneath the night sky, seeing something that didn't belong, unable to tell if it was divine or mechanical. The same feeling echoed through every dataset. Teams compared timestamps down to the millisecond. The pulses were perfectly synchronized. Some argued it was solar interference, others that our sensors were picking up the harmonics of a distant plasma wave. But none of those explanations survived scrutiny. The phase alignment was too precise, the noise too clean. And then came the strange beauty of it. When we overlaid the light curves from every observatory, they fit together, like pieces of glass, transparent layers, forming one perfect rhythm. When the universe speaks in harmony, across instruments, you start to wonder, maybe it isn't noise at all. Maybe it's something trying to be heard. I remember walking out of the lab that night, looking up at the dim winter sky, thinking about the simplicity of that signal. It reminded me of a heartbeat on an electrocardiogram, steady, purposeful, alive. Of course, that's just metaphor, but still, the resemblance was unsettling. Because if light is information, and information has structure, then structure implies design, or at least a process repeating itself for a reason, and that reason, whatever it was, didn't seem random. One of the graduate teams at the Royal Observatory decided to test a hypothesis. What if the signal was a modulation caused by rotation? If the comet's surface reflected sunlight unevenly, like a lighthouse beam sweeping across space, perhaps that could explain the pattern. They built a simulation, spinning a digital model of 3I Atlas, adjusting its reflectivity, its axis tilt, its velocity, but no configuration produced the clean, rhythmic peaks we observed. Nature, it seemed, preferred chaos. 3I Atlas was dancing to its own tune. There was a growing discomfort in the community. To admit something truly anomalous was to step outside the comfortable walls of known physics. Still, some did. I remember a quiet conversation after midnight, a small circle of us around the flickering screens. One voice whispered, "What if it's being modulated?" Another said, "By what?" No one answered. We just watched the data pulse again, as if the object itself was breathing. And that's the thing about science, you see. It doesn't deal well with poetry. We prefer certainty, equations, and models that predict outcomes. Yet here we were, staring at a rhythm that fit none of them. It was almost musical. 3 beats, silence, 3 beats again, regular, repeating, relentless. Some even converted the frequency into sound, letting the pulse play through speakers in a darkened room. It was eerie, a low, throbbing hum that felt almost intentional. The first formal papers came out within weeks. Interference pattern, phase error in multi-telescope synchronization, atmospheric noise in distributed arrays, all attempting, politely, to explain away the impossible. But then, one by one, the rebuttals arrived, independent verification, cross-checked and confirmed. The phase coherence held across all instruments. There was no instrumental bias, no shared reference error, no atmospheric coupling. The pulse was real. Well, at that point, things began to change. The tone of discussion shifted from dismissal to curiosity, from skepticism to awe. I think that's when we began to accept that we might be witnessing something nature had not shown us before. Perhaps not intelligence, but some deeper pattern, an emergent order within chaos. The researcher from Prague noticed something strange when analyzing the brightness curve in relation to the sun's position. The peaks were not only regular in time, they were geometrically aligned with the object's perihelion arc. That meant whatever caused the modulation was also aware, in some sense, of its orbital geometry. That's when the word synchronization began to appear in discussions. Synchronization implies feedback. Feedback implies control. And control, well, that implies intent. Some of us resisted the temptation to leap into science fiction. We looked for natural explanations. Plasma storms, rotational harmonics, resonant vibrations caused by internal cavitation. Each hypothesis was elegant, and each fell apart under the weight of precision. 3I Atlas wasn't behaving like rock and ice. It was behaving like a system, a coherent one. There's a quiet fear that grows when data refuses to behave. It's not fear of the unknown exactly, but of the known not being enough. Every time we thought we had it pinned down, the next observation deepened the mystery. The pulse shifted slightly in amplitude, as if responding to solar pressure, yet the interval stayed perfect. Some called it the most beautiful anomaly in modern astronomy. Others, a statistical trick waiting to be disproved. I suppose the truth is that anomalies are invitations. They remind us that nature doesn't owe us simplicity, it owes us wonder. When I think of those 3 peaks now, I no longer see them as noise, or even as data. I see them as questions, carved in light, drifting through space. What could produce a heartbeat in the vacuum? What could sustain it across millions of kilometers? The deeper we looked, the stranger it became. Instruments sensitive to polarization detected subtle oscillations, synchronized with the light pulses, suggesting the source of reflection was rotating magnetic material. But again, no natural comet has ever shown such precision. The pattern, repeated exactly before, during, and after perihelion, defying the violent outgassing that usually tears comets apart near the Sunday. It was as though the object anticipated the solar storm and adjusted itself, keeping its rhythm undisturbed. And in that rhythm, there was a whisper of something profound, a harmony that seemed to defy entropy, as if the object existed not to decay, but to persist. Perhaps, that's what intrigued us most. Not that it was alive, but that it behaved as though it wanted to remain whole. The more data we collected, the more it felt like listening to a cosmic metronome, marking time against our understanding. Each pulse a reminder that we might be missing something, some deeper layer of physics that allowed matter and energy to act in concert. And maybe, just maybe, that was the point. One evening, after the third data release, I remember standing by the console as the light curve unfolded in real time. Every 20 minutes, another rise, another fall, perfectly on schedule. It felt absurdly intimate, like watching the slow breathing of a sleeping giant. I caught myself whispering, "Who are you?" Not expecting an answer, but unable not to ask. We decided to probe deeper, to move beyond light, and examine heat. If the pulses were real, they should have corresponding changes in temperature, heat rising and falling in rhythm with brightness. It was a simple test, elegant and dangerous. Because if the pattern held there too, then 3i Atlas wasn't just reflecting sunlight, it was regulating itself. And so, as the instruments recalibrated and the first thermal readings began to appear, something within all of us tightened. The heartbeats of light had already changed how we looked at comets. Now we were about to learn whether the pulse carried warmth too, whether the object that shimmered in the light of the sun could, somehow, feel its own heat. The first thermal readings arrived 3 nights later, and they changed everything. The numbers came in quietly, without any fanfare, just rows of figures glowing faintly on a cold monitor in the control room. At first glance, they looked ordinary enough. A slow rise in surface temperature as the object neared the sunday. Predictable, consistent, natural. But then, as the instruments continued to track the signal, a subtle oscillation began to emerge, perfectly synchronized with the pulses of light we had seen before. Every time the brightness peaked, the temperature dropped. Every time the light dimmed, the heat rose. It was upside down, completely inverted. You see, in ordinary physics, heat follows light. A comet warms as it absorbs sunlight, and its brightening comes from that heat releasing gases and dust into space. But 3i Atlas refused to obey. It seemed to cool itself precisely when it should have been burning hottest. It was as if the object had learned to protect its surface, to preserve itself in the face of solar fire. At first, the team thought it might be a sensor lag, some delay between photon detection and thermal response. But no, the phase difference was too perfect, too intentional. It wasn't a delay, it was a counter-rhythm, a heartbeat in reverse. We began mapping the thermal data onto a 3D model of the object's rotation. The pattern became clearer. The hemisphere facing the sun would suddenly drop in temperature just as the opposite side, in darkness, warmed up. It was a seesaw of energy, a kind of internal balance that kept the average surface temperature almost constant, despite the furious heat of its orbit. Some of us joked that the comet was breathing, inhaling sunlight and exhaling warmth, maintaining equilibrium like a living organism. But under the quiet hum of the control room, no one was really laughing. When I looked at the simulation, I remember feeling a strange calm. It was beautiful, in a way that science rarely allows itself to be. Imagine it, a frozen traveler from beyond, the solar system, wrapped in dust and ice, passing near the sun, yet refusing to burn. Each pulse of light matched by a pulse of heat, as if it were regulating its own survival. And that's the thing. The longer we studied it, the harder it became to describe 3i Atlas as just a rock. The physicists began arguing about thermodynamics. A passive body cannot cool itself faster than it absorbs energy, one of them said, tapping the equations on the board. Unless, another replied softly, it isn't passive. That sentence lingered in the room like a slow echo, not passive. The idea was absurd, but it fit the data too well to ignore. So, we searched for mechanisms. Could the surface be metallic, reflecting more light at certain phases? Could subsurface layers channel heat away from the sunlit side, transferring it across internal veins of conductive material? It was far-fetched, but when we adjusted our models to include high thermal conductivity, something akin to nickel alloys, the data snapped into place. The simulation matched the real signal with eerie precision. And yet, that created an even stranger problem. Natural comets don't contain pure metallic veins. They're dirty snowballs, ice, rock, carbon dust. But 3I Atlas, whatever it was, seemed to have a surface capable of redistributing heat like a machine. Some called it coincidence. Others whispered a different word: design. I remember sitting alone that evening, replaying the sequence of temperature changes on a loop. The waves of heat and light danced together like a duet, one rising as the other fell, always in harmony. It reminded me of biological feedback, the way a body regulates its temperature, the way a cell adapts to stress. Could an inanimate object really mimic the behavior of life? Or, perhaps, is life itself just a pattern of feedback written deep into the laws of matter? We pointed the infrared array again, trying to catch finer variations. What we found next was even harder to believe. During the brief window when the object passed its perihelion, the hottest point in its orbit, the dark side of 3I Atlas, shielded entirely from sunlight, glowed brighter in the infrared spectrum than the sunlit hemisphere. That shouldn't happen. It was like watching the night side of a planet shine more intensely than its day. Something is transferring energy internally, said Dr. Eames, leaning over the screen. But there's no mechanism for that in a solid comet. We tried to model convection, subsurface vapor pockets, anything that could create such rapid phase inversion. Nothing fit. The timescales were too short. Heat doesn't move that fast through rock or ice. It was as though the energy flow wasn't thermal at all, but something else. Something electromagnetic, perhaps, responding to solar flux in a way we didn't understand. And then came the strangest discovery of all. When we charted the thermal variations against the Perihelion, the rhythm of the light pulses, we realized they weren't just synchronized, they were entangled in perfect opposition. The peak of brightness coincided exactly with the lowest temperature, like two parts of the same equation balancing each other. It was the most elegant symmetry any of us had ever seen in nature or in something pretending to be nature. One researcher, half in jest, said it reminded him of a control system, an adaptive feedback loop. But that word, control, unsettled the room. Control implies awareness. Awareness implies something closer to will. And no one was ready to say that out loud. Perhaps, I suppose, what disturbed us most wasn't the data itself, but what it suggested about the boundary between life and matter. If an object can regulate heat, balance itself against radiation, and maintain structure near the sun, does that make it alive? Or does it simply redefine what we mean by life? At one point, a young scientist drew a parallel between 3I Atlas and extremophiles on Earth, organisms that thrive in boiling vents or frozen deserts, bending the rules of survival to fit their environment. Maybe, she said quietly, this isn't a machine. Maybe it's a form of matter that learned to adapt long before life as we know it did. It was a haunting thought. Because adaptation requires feedback, and feedback implies intention, even if only at a physical level. The comet, or whatever it was, seemed to possess a kind of resilience, a refusal to yield. And perhaps that's what truly captivated us. It wasn't technology we were looking at, nor biology. It was something in between, something that made the distinction feel smaller than we'd ever imagined. Over the following days, the instruments caught a new pattern, small fluctuations within the larger thermal wave, like subtle tremors layered beneath the main rhythm. They appeared as the object began to rotate faster, its spin aligning with the solar plane. That alignment shouldn't have been possible. A comet's jets, bursting unpredictably from beneath its crust, usually throw it into chaos. Yet 3I Atlas rotated smoothly, almost elegantly, maintaining its orientation even as it endured solar winds strong enough to shred ordinary bodies. You see, when a system behaves that way, stabilizing itself against external forces, you begin to sense geometry at work. Geometry is the language of intention. The object wasn't resisting the sun, it was dancing with it, adjusting its rotation and heat flow as though following a choreography older than our equations. And that led us to the next puzzle, one that would keep us awake for weeks. If the light was modulated and the heat was balanced, then what about motion? What if the forces acting on 3I Atlas jets, radiation pressure, gravitational tugs, weren't random at all, but coordinated? Late one evening, I found myself staring at the last frame of the thermal map, the dark side glowing. Softly, as the bright side cooled, it was serene, almost peaceful, like the surface of a breathing world. I thought about how fragile our definitions are, how easily the universe reminds us that natural and artificial are just words we invented to make ourselves feel secure. Perhaps, in its own silent way, 3I Atlas was teaching us something about survival. To endure near the sun, it did not fight the heat, it redirected it. To remain stable, it did not resist motion, it harmonized with it. Maybe that's what intelligence looks like at a cosmic scale, the ability to persist by balance, not by dominance. And yet, the data kept deepening. As we tracked the object beyond its closest approach, the thermal pulses began to merge with subtle fluctuations in reflected plasma, hinting at jets or outflows, forming patterns far too symmetrical to be random. The light, the heat, the motion, all seemed to be part of the same rhythm. We didn't know it then, but the next set of measurements would challenge even the boldest of our assumptions. For as 3I Atlas turned away from the sun, its jets began to reveal something extraordinary, not chaotic eruptions, but precise, geometric streams of plasma, each aligned like a spoke around a perfect axis. And that was when we realized the rhythm we'd been following might not end with light and heat. It might extend into motion itself. And then, almost as if to answer that suspicion, the data began to change. The rhythm that had once lived only in light and temperature now revealed itself in motion. As 3I Atlas drifted away from the sun, faint threads of plasma unfurled from its surface at first, soft and uneven, then settling into clear, deliberate lines. They glowed with a pale intensity, forming patterns too precise to be random. At first, they seemed like the kind of jets one would expect from a comet, bursts of gas escaping from cracks in the ice, reacting to solar heat. But the symmetry was impossible to ignore. 3 equidistant streams, forming a perfect triangular frame that rotated with the body itself. Each plume flickered in harmony with the light pulse we had seen earlier. The correlation was exact, down to the second. You see, natural comets don't behave like that. They're chaotic creatures, their surfaces fractured and uneven, their outgassing random. When a jet bursts, it kicks the nucleus off balance, altering its spin and tumbling it into unpredictable motion. But 3I Atlas spun with eerie steadiness, its rotation axis holding firm despite the violence of solar radiation. Every burst of plasma seemed to counteract the previous one, maintaining equilibrium. It was as if the object understood the laws of physics and used them to keep itself upright. Perhaps that's what stunned us most, not just the precision, but the intent it seemed to imply. When the data from multiple observatories was combined, the pattern became even clearer. Each jet was aligned exactly 120 degrees apart, all emerging from equatorial coordinates that remained constant throughout observation. Even the slightest deviations caused by solar wind, magnetic turbulence, gravitational perturbations were compensated for within minutes. The object wasn't just stable, it was self-stabilizing. We began to ask ourselves, quietly at first, could the plasma jets be functioning as a control system, a mechanism to maintain spin? It was a dangerous thought, bordering on heresy in a field that prized natural explanations. Still, the evidence kept pointing that way. The rotation rate wasn't constant, but oscillated rhythmically, accelerating slightly with each light pulse, then easing back, only to rise again. The period of these fluctuations matched the thermal and luminous cycles we had measured earlier. Light, heat, motion all synchronized. When nature arranges phenomena with that kind of unity, it's hard not to wonder whether something deeper is at play. One evening, as we watched the new telemetry data stream in, I remember feeling the weight of that realization settle over the room. The graphs on the monitors no longer looked like random data points, they looked like choreography. Each jet firing, each oscillation, each subtle shift in spin, everything happened in time, in rhythm. The object was performing a dance in space, one that seemed both graceful and deliberate. Dr. Heller, one of the more skeptical voices in our group, leaned forward and whispered, "Maybe it's just coincidence. A perfect storm of symmetry. Another replied softly. Coincidence doesn't repeat itself this many times. We modeled the dynamics again. In every simulation of a natural comet, jets cause the body to precess wildly, throwing it off axis within hours. But when we added controlled counterjets at precise intervals, the motion became identical to what we observed. The math didn't lie. To maintain that kind of balance, the main object would need to monitor its spin and adjust thrust accordingly. Which meant, well, you see the problem. That night, as the sun dipped below the horizon of our observatory, I stepped outside. The sky was a soft wash of violet and gold, the last light of day dissolving into the endless black beyond. Somewhere out there, that strange traveller was turning slowly in the solar wind, its geometry locked in perfection. I couldn't shake the thought that we weren't just observing a natural process. We were witnessing intention made visible through physics. Still, we resisted the word artificial. It felt too heavy, too final. Instead, we called it non-random coherence. It was our way of preserving scientific distance, even as our curiosity pulled us closer to wonder. Over the next days, our measurements grew more refined. High-resolution spectroscopy revealed that each jet emitted plasma at slightly different temperatures, yet all carried the same mass flow rate. That balance made no sense. Natural jets vary wildly depending on local composition and pressure, but here, each behaved like a calibrated nozzle, fine-tuned to maintain thrust equality. When one weakened, the others intensified to compensate. The system responded like a gyroscope correcting itself. At some point, Doctor, Eames said quietly, it's like it wants to keep spinning. And the truth was, that's exactly what it looked like. In a purely mechanical sense, such behavior could arise from self-organizing feedback energy, finding the most stable configuration through constant readjustment. But in practice, this required precision beyond what chance could produce. The comet wasn't resisting external forces, it was cooperating with them. It was, in a strange and beautiful way, listening to the Sunday. You see, the laws of motion are universal, but how an object uses them can vary. We tend to think of celestial bodies as passive rocks hurled by gravity, bound by momentum. But 3I, Atlas defied that image. It behaved more like a system that understood its environment and adjusted its dynamics to remain whole. It wasn't merely surviving the sun, it was thriving within its energy. The plasma plumes, when seen through ultraviolet filters, shimmered like wings of light. Each beam flickered at a frequency that matched the main light curve, a resonance that seemed too poetic to be accidental. There was something almost musical about it, as though the object was responding to the cosmic rhythm around it, the pull of gravity, the push of radiation, the hum of charged particles. I suppose that's what science often forgets, that even in the cold vacuum of space, there is a kind of harmony at work. The universe doesn't move randomly, it composes. And yet, harmony alone wasn't enough to explain the next thing we found. The angular momentum of 3I Atlas wasn't just stable, it was quantized, shifting in discrete steps, as if the object were adjusting itself at specific intervals. Every adjustment coincided with a peak in the light curve. Each time the object brightened, its spin changed by exactly the same fraction of a degree. It was so consistent it could have been a metronome. Some called it a resonance lock, a natural feedback between internal structure and solar radiation. Others whispered, half in awe, that it might be a form of control. The term artificial stability appeared in one draft of a paper, then was hastily removed before publication, but we all saw it. We all knew what it meant. Perhaps the truth was simpler. Perhaps, somewhere between chaos and order, there exists a boundary where matter itself learns to adapt, where physics becomes a kind of intelligence, not conscious, but responsive. 3I Atlas might be the first thing we've seen that lives on that boundary. As the days passed, the object continued its strange, deliberate motion, its 3 jets glowing faintly against the dark. They formed a rotating triangle that never wavered, never collapsed, as though locked to some internal compass. And yet, amid that stability, something else began to change. The timing of its light pulses, those perfect, heartbeat-like rhythms began to drift, just slightly, as if it were entering a new phase. The pattern was subtle, almost imperceptible at first, but soon undeniable. The rhythm we'd come to rely on light, heat, plasma was slipping out of sync. Something was interfering. Instruments across multiple stations began to record small anomalies, fluctuations in radio background, distortions in the object's spectral lines, even slight shifts in our timing data. It was as though the space around 3i Atlas was bending, warping the signals we used to track it. And then, one by one, the telescope started going dark. First came the southern network Chile, then Australia. Their feeds froze mid-frame. Then the northern stations followed Hawaii, La Palma, and finally, the orbital sensors. Within 2 minutes, every system watching the object lost contact. For nearly 2 hours, the universe went silent. No one spoke. We just watched the empty data screens, hearts beating in unison with the void. Because deep down, every one of us understood what silence meant. Something had happened not to our instruments but to the object itself. When 3i Atlas reappeared, it looked different. Its light had shifted in color, its signature spectrum altered, as though it had shed a layer or changed form. Whatever it was doing out there in that 2-hour darkness, it had come back transformed. And as we began to piece together the fragments of missing time, we realized that the next question wasn't about symmetry or motion anymore. It was about disappearance and what can happen when something vanishes, even for a moment, into the folds of the unknown. For nearly 2 hours, the cosmos held its breath. Every telescope, every array, every receiver trained upon 3i Atlas recorded nothing but stillness, an emptiness so absolute it felt intentional. No light, no radio echo, no plasma signature, no trace of heat. Just a perfect, blank silence. It wasn't a loss of signal in the technical sense. It was a loss of presence. The object had, for all measurable purposes, ceased to exist. At first, we thought it might be interference, a solar flare perhaps, or a burst of electromagnetic noise washing through the system. But the sun was calm, its corona unperturbed. There were no storms, no flares, no anomalies anywhere near the spectrum we were observing. And yet, every instrument on Earth and in orbit showed the same gap, the same 2 missing hours. You see, when one telescope fails, we blame the machine. When all of them fail, we begin to suspect the universe. The data logs from the observatories told an unnerving story. Each system froze at precisely the same timestamp, down to the millisecond. Each clock stopped recording exactly when 3i Atlas should have crossed the narrowest point of its orbit, the moment when the sun's radiation would be at its fiercest. Then, at the end of that void, as suddenly as it vanished, the signal returned. Only now, it was different. The spectrum had changed. The object's light was redder, deeper, its intensity smoother and more constant than before. The plasma jets, once crisp and symmetrical, now flickered with faint halos of magnetic interference. It was as if something had reconfigured itself, as though the traveler had shed one skin and emerged cloaked in another. We stared at the first recovered image in silence. The shape was familiar, but altered edges blurred, albedo redistributed, a subtle distortion across the reflective surface. The geometry wasn't wrong, but it was no longer exact, as if the object we'd been studying had been replaced by its own reflection. Dr. Eames was the first to break the silence. "It's not just the light," he said. "Look at the timing." He pointed to the heartbeat pulses that had once defined the object's rhythm. They were still there, but out of step, shifted by a fraction of a second. The phase alignment that had held constant for weeks had drifted. "What does that mean?" someone asked. He looked up, eyes fixed on the glowing waveform. "It means something happened to its time. You see, that's the thing about time. We think of it as absolute, a steady river flowing forward. But in physics, time is elastic, bending to gravity, motion, and mass. When an object passes near a strong field, its clock can slow down relative to ours. And yet, there was nothing near 3i Atlas that could have caused such distortion. No planet, no anomaly, no measurable gravitational gradient. Whatever had interfered with it had done so from within. We started calling it the lost interval. 2 hours of universal silence, a hole in our measurements that no model could fill. The light before and after lined up perfectly, as if nothing had happened, yet all the intervening data was gone. In a way, it was like finding a missing page in a book, only the story continued, as if the page had never been written. Perhaps, I suppose, that was the most unsettling part. The universe is supposed to conserve information. Nothing truly vanishes. It transforms, it hides, but it does not simply disappear. And yet, here we were, staring at a piece of sky where the laws of conservation had quietly stepped aside. The more we analyzed it, the stranger it became. Spectral analysis revealed new absorption lines, faint traces of elements we hadn't seen before, as though the object's outer layer had been burned away to reveal something beneath. Iron, nickel, and traces of carbonyl compounds, their ratios too clean, too consistent to occur naturally. And the heat signature, oh, the heat was wrong in every way. Instead of peaking near perihelion as expected, it dipped sharply, suggesting that during those missing hours, the object had cooled instead of heated. It was impossible, and yet the numbers didn't lie. One researcher proposed that the object had somehow rotated its reflective surface away from the sun, minimizing exposure. Another suggested that a temporary field, perhaps magnetic, perhaps something else had enveloped it, shielding it from radiation. But all those explanations shared the same flaw. They required an action, a mechanism, a response. And comets don't respond, they react. Still, 3I Atlas had reacted with precision. Its cooling, its spectral shift, even its new geometry, all pointed toward an active process of transformation. Something inside it had changed. I remember, late one night, scrolling through the recalibrated data streams, watching the faint heartbeat pulses realign. For a moment, I imagined the object as a chrysalis in the fire of the sun entering the light, vanishing and emerging, reformed. Perhaps that silence wasn't a disappearance at all. Perhaps it was an event. The following week, new instruments were trained on the object. Radar arrays, radio telescopes, magnetometers, all aimed to probe its altered state. What they found defied prediction. The reflected radar signal came back doubled, as though it had bounced off not one surface, but two. There was interference, a ghost image offset by microseconds, hinting at a thin layer something surrounding the core like a shell of ionized gas. Theorists speculated wildly. Some said the outer crust had vaporized and recondensed. Others whispered about phase transitions matter shifting between states we didn't yet understand. But for all our theories, one fact remained undeniable. The object we were watching after the lost interval was not the same as the one that entered it. There was an almost sacred quiet in the lab when we plotted the before and after profiles. The change wasn't catastrophic. It was elegant. The new surface reflected more light at shorter wavelengths, its albedo, increasing even as it cooled. The internal temperature oscillations that once matched the light curve now flattened, as though the system had achieved thermal equilibrium. It had become efficient. You know, that's what struck me most deeply. Efficiency is a kind of intelligence. It's what evolution strives for, what technology mimics, what the cosmos seems to admire. 3. Atlas wasn't resisting its environment, it was learning from it. The lost interval was its lesson. Still, there was one more anomaly we couldn't ignore: the timestamps. When the signal returned, every observatory's atomic clock was out of sync by the same margin, exactly 7.2 seconds. It was as if time itself had bent around the object and snapped back slightly displaced. The synchronization error wasn't in our systems, it was in the cosmos, and that realization chilled us. Because when multiple independent clocks drift together, the source of distortion isn't human. It's physical. We rechecked everything: satellite timing, Earth's rotation, even gravitational fluctuations. Nothing accounted for it. The only consistent factor was the presence of 3 Atlas at the exact moment of loss. It was as if, for 2 hours, it had stepped outside of time's flow, and when it returned, it brought a subtle ripple with it, a wrinkle in the fabric of now. Dr. Heller, who rarely spoke in metaphors, murmured quietly, "Maybe it wasn't gone. Maybe it just wasn't here." And I suppose that idea, unsettling as it was, fit perfectly with what we saw next. In the days that followed, the object's orbit began to deviate ever so slightly from its predicted course. A tiny acceleration, non-gravitational in origin, nudged it downward toward the plane of the solar system, as though it were seeking alignment with the planets. A movement both deliberate and graceful. We didn't know it yet, but that drift, the subtle, steady descent of 3I Atlas toward the ecliptic, would soon raise even deeper questions. Questions about direction, intention, and the faint but unshakable possibility that we were no longer observing a comet, but witnessing a will embedded in motion itself. The spectral data that came after the lost interval changed everything. For weeks, we had been analyzing the light of 3I Atlas as though it were a mirror, its reflections telling us the story of its surface, its composition, its dance with sunlight. But what we found next didn't just tell a story, it rewrote it. At first, the reading seemed inconsistent, full of noise, thin spikes, and troughs scattered across the visible and near-infrared bands. But when we filtered the solar background and recalibrated the instruments, a pattern began to emerge. Every few minutes, right at the crest of the light pulse, a new signature appeared: nickel vapor. The spectral line of elemental nickel, sharp and clean, cutting through the chaos like a fingerprint. Nickel is not uncommon in the cosmos. It exists in meteorites, in planetary cores, in the dense hearts of stars. But in comets, it's rare and never pure. Normally it's mixed with iron, sulfur, carbon compounds, and dust. But here, the ratio was immaculate: 98% nickel by emission intensity, repeating in cycles that matched the object's light rhythm. It was as though the comet was exhaling metal in perfect time, with its own heartbeat. That discovery alone would have been enough to unsettle us. But the chemical story deepened. As we examined the secondary bands, we found traces of nickel tetracarbonyl, an unstable compound that forms only under very specific conditions: high temperature, low pressure, and the presence of pure carbon monoxide. It is, incidentally, one of the most toxic and volatile substances known to human chemistry. On Earth, it's used in metallurgy to refine nickel into high-grade alloys. The process requires precision engineering and tightly controlled environments. And yet, somehow, it was happening in the vacuum of space. I remember staring at the graph, the spectral peaks glowing red on the screen. The data was unambiguous. This wasn't contamination or noise, it was a process. Nickel, vaporizing, bonding with carbon monoxide, recombining in cycles. The ratios remained constant, the timing exact. Every pulse of light coincided with the release of metallic compounds, as though the object were venting, or refining, or both. One of the chemists whispered, almost involuntarily, "It's manufacturing." Of course, no one said that aloud in the reports. We spoke instead of periodic chemical modulation, of reactive surface restructuring. But the implication lingered. Natural comets are chaotic. Their chemical spectra are dirty, irregular, constantly shifting. Yet this one was clean, deliberate, almost elegant. It was the difference between smoke and signal. When we compared the data before and after the lost interval, the transformation became even more striking. Prior to the blackout, the spectrum was dominated by silicates and carbon compounds, typical cometary dust. Afterward, the silicates were gone. In their place, a consistent presence of nickel vapor, carbonyls, and trace elements of chromium and vanadium, metals known for their resilience to heat. It was as though 3I Atlas had shed its skin of stone and revealed a metallic core beneath. You see, the universe has its own logic of survival. The closer a body comes to the sun, the more it must adapt or perish. But this adaptation seemed premeditated. The ratios of metal to carbon were tuned to perfection, forming a layer capable of reflecting solar radiation with almost no absorption. Its surface temperature remained stable, even under conditions that should have melted any natural material. When we plotted the reflectance curves, they matched the properties of heat-resistant alloys used in human spacecraft, particularly those engineered for plasma exposure. It was an uncomfortable coincidence. The numbers aligned too neatly. Reflectivity, near 90%, emissivity, balanced across the infrared range, and structural persistence through sustained thermal flux. and that's when someone, half in jest, called it the mirror skin. The name stuck. The mirror skin behaved like a living interface, absorbing energy, redirecting it, regulating itself. It wasn't just surviving perihelion, it was thriving within it. Every burst of radiation from the sun seemed to trigger a chemical response, renewing the layer of nickel vapor, sealing it tighter, polishing it brighter. It was a cycle of destruction and repair, like a body healing its own wounds. Perhaps, I suppose, it wasn't unreasonable to think of it as self-maintaining. But how could a natural object develop such an ability? Some proposed that it was a relic from the earliest days of the galaxy, a fragment of metal-rich debris shaped by eons of radiation, hardened by cosmic storms. Others dared to imagine something even stranger, that it wasn't formed, but forged, a manufactured fragment, drifting between stars long after its makers were gone. We didn't know which idea was more unsettling, that nature could produce something so precise, or that intelligence could leave something so abandoned. At night, I found myself thinking about entropy, the great equalizer of the cosmos. Everything decays, breaks down, turns to dust. And yet, here was something defying that rule. Every interaction with energy made it stronger, more ordered. It wasn't entropy, increasing it was reversing. The second law, rewritten in nickel and light. We began to analyze the spatial distribution of the emissions, using interferometric imaging to map where on the surface the metals were venting from. To our astonishment, the pattern wasn't random. The outgassing originated from 3 points, precisely the same coordinates as the plasma jets we had seen earlier. The geometry persisted. The same triangle, the same rhythm, now pulsing not just with light and heat, but with chemistry. Light, heat, motion, metal. It was as if every layer of the object's behavior echoed the same principle: stability through rhythm, control through balance, each system reinforcing the others. A unity that felt engineered, even if it wasn't. Somewhere deep within the datasets, Dr. Heller found something that still haunts me. During the brightest peaks, the nickel vapor wasn't just emitted, it was ionized. That meant the metal wasn't escaping into space. It was being accelerated, guided along magnetic fields. Those fields aligned perfectly with the plasma jets. The implication was clear. The object was using metallic plasma to steer. You see, propulsion doesn't always mean engines. It can mean geometry, charge, and light. And if 3I Atlas had learned to manipulate those, then it wasn't merely reacting to the sun, it was conversing with it. The phrase that kept returning to me was responsive matter, a structure that doesn't just endure the environment, but interacts with it. Like a sail that adjusts itself to the wind, not by command, but by instinct. Could such a thing exist? Could material itself be intelligent, programmed not through code, but through chemistry? The line between science and wonder grew thin. We watched the nickel bands flare and fade, the carbonyl compounds rising and dissolving, the object shimmering like a forge suspended in sunlight. There was a rhythm to it all, a strange serenity in the chaos of reactions. And then came the final, quiet revelation. When we averaged the data across multiple observation cycles, we discovered that the metal emission rate was constant, not in absolute value, but in proportion to the object's apparent acceleration. The faster it moved, the more it vented. The venting wasn't a byproduct, it was a force. 3I Atlas was propelling itself, not dramatically, not with the roar of rockets or the flare of exhaust, but with a whisper, a gentle, continuous pressure, born of chemistry and magnetism. Each cycle of vaporization, ionization, and release nudged it forward, guiding it like a sail catching the invisible wind of solar particles. The realization left us both terrified and awestruck, because propulsion, no matter how subtle, implies direction, and direction implies purpose. We didn't know what that purpose was. Perhaps it was nothing more than the unconscious persistence of matter, finding its most stable path, or perhaps it was something more, a quiet intention, encoded in the very design of the thing. Either way, the evidence was undeniable. The chemical composition of 3I Atlas wasn't static, it was dynamic, reactive, purposeful. It had learned or been built to move through fire without being consumed. As the object began its slow, deliberate descent toward the plane of the solar system, We couldn't help but feel that it was choosing to. The metals, the jets, the rhythm, they weren't random phenomena. They were the language of motion. And somewhere in that language, hidden between the lines of spectra and the hum of magnetic fields, we began to sense that the next mystery waiting to unfold wouldn't be chemical at all. It would be one of force, of gravity, of the subtle act of guiding one's own path through the cosmos. For even as we studied its glow, 3I Atlas was already changing course, slowly, silently aligning itself with the invisible plane where all the planets move, as though it wished to join their endless dance around the Sunday. It began with a deviation so small it could have been missed a fraction of a degree in the orbital inclination of 3I Atlas, just enough to raise an eyebrow in the tracking data. At first we dismissed it as a rounding error, an echo of gravitational perturbations from Jupiter or the solar wind's uneven push. But the change persisted. Night after night, the numbers crept in the same direction, subtle yet unwavering. The comet, if we could still call it that, was lowering itself toward the ecliptic plane, aligning its path with that of the planets. It shouldn't have been possible. A body emerging from deep interstellar space, hurled into a hyperbolic trajectory, should have passed through our system like a stone through water, deflected, not guided. Yet 3I Atlas was bending its course, not in a chaotic spiral but through a smooth, continuous arc. The orbital elements shifted in ways that could not be explained by gravity alone. Something was applying a steady, directional force. You see, non-gravitational acceleration is not new in comet science. When volatile gases erupt from a sunlit surface, they can push the body slightly, altering its path. But those accelerations are irregular bursts and flickers, the signatures of randomness. 3I Atlas was different. The acceleration was constant, rhythmic, and perfectly synchronized with its light and chemical cycles. Every time the nickel vapor flared, the object's velocity changed by the same precise amount. It was propulsion by chemistry, but controlled with an elegance that nature rarely achieves. We tried to model it using known forces: solar radiation pressure, outgassing, magnetic drag. None fit. To sustain the measured trajectory change, the object would have needed to generate a thrust equal to several hundred newtons, distributed evenly across its motion. Yet the venting jets were too small to produce that by accident. Unless, of course, they were not accidents at all. Dr. Eames suggested a comparison with Solar Sail's theoretical spacecraft that used the momentum of photons for propulsion. If its surface acts like a mirror, he said, then sunlight itself could be the engine. And indeed, the reflective properties we'd measured from the nickel-carbon layer made the idea plausible. The efficiency was extraordinary. Every photon striking, its surface seemed to bounce perfectly, transferring energy without absorption. But the directional control was what baffled us. A simple reflective body would drift outward, pushed randomly by light. This object, however, steered. It turned its reflective face toward the sun when it needed speed, then tilted slightly, adjusting its angle as though it understood the vector of each force acting upon it. I suppose that was when we began to sense intention, not conscious, perhaps, but deliberate, like a seed carried on the wind, yet shaped to find the right current. The more we watched, the clearer the pattern became. The bright pulses, the venting cycles, the slow orbital drift, all worked together as a single, unified mechanism. It wasn't being pushed by the sun, it was using the Sunday. And that's the thing, the universe doesn't waste energy. Everything that endures learns to flow with the forces around it, not against them. 3I Atlas embodied that truth. It had become a mirror not only to light, but to motion itself, a cosmic sail adjusting to the breath of a star. The orbital analysis team released their preliminary report in late spring of 2025. The conclusion was understated, almost timid. Observed trajectory deviations are consistent with continuous non-gravitational acceleration. But buried in the appendix was the real revelation. The direction of that acceleration wasn't random. It pointed consistently toward the ecliptic toward us. When the press got hold of it, they called it the comet that chose a lane. But within the scientific community, the tone was quieter, more reverent. Some argued it was a natural alignment caused by the gravitational harmonics of the inner planets. Others, however, whispered that we were witnessing the first recorded instance of autonomous motion by an interstellar object. In the control room, we spent long hours watching the simulations. The models showed the comet gradually, flattening its orbit until it nearly matched the plane of Earth, Mars, and the rest. The transition wasn't abrupt or forced, it was graceful, like a dancer descending into perfect balance. Even the angle of the plasma jets adjusted over time, as though compensating for the changing geometry. Each movement seemed calculated, purposeful, serene. Perhaps I thought that was its survival strategy, not to fight the gravitational tides of the sun, but to blend into them, to join the great cosmic order where the planets move in their silent, endless harmony. And there was poetry in that, an interstellar visitor arriving from chaos, finding its place among the circles of light. The image haunted me. What kind of object chooses to belong? Meanwhile, the data kept flowing. We detected faint electromagnetic oscillations accompanying the acceleration, subtle variations in the radio band that repeated in sync with its light pulses. They weren't signals, not in any communicative sense, but harmonics waves generated by plasma interacting with solar radiation. Yet the pattern was too coherent, too deliberate. The frequencies rose and fell with each orbital correction, forming a resonance that mirrored the object's trajectory. It was as if the entire system, the jets, the metals, the light, was resonating with the sun's magnetic field, feeding off its energy like a tuning fork humming to a note. Dr. Heller proposed that the object might be using the sun's magnetic flux lines to generate thrust, a form of magnetoplasma sailing. The idea was speculative, but strangely fitting. In theory, charged particles emitted from the surface could interact with the solar wind, creating a continuous push. By modulating its emissions, the object could control direction. It would need no engine, no fuel, just the star itself. We ran the math. It worked, not perfectly, but closely enough to make the hypothesis impossible to ignore. If true, then 3I Atlas wasn't merely drifting, it was navigating. I remember the moment that realization sank in. The room fell silent, not with excitement, but with awe. Because navigation implies awareness, not consciousness, as we understand it, but responsiveness, the ability to perceive environment and act upon it. And that blurs the line between the living and the inert. You see, perhaps that's what life really is, not biology, but the capacity to adapt in rhythm with the cosmos. We watched for months as the object continued its descent toward the ecliptic, its motion so smooth it resembled a glide. The sun's radiation pressure should have slowed it, yet it maintained velocity. When it passed near the orbit of Venus, it performed what could only be described as a maneuver, adjusting its angle to avoid excess heating, then resuming course. The precision was breathtaking. There were nights I would step outside, look up at the faint shimmer of its reflected light, and wonder what it was doing or becoming. Was it learning? Was it following some ancient trajectory encoded in its structure? Or was it simply obeying the mathematics of balance, finding the one path through chaos that promised continuity? In the language of physics, we called it self-regulating motion, but in quieter moments, I thought of it as grace. As the orbit flattened further, our instruments began to detect a change in its reflected spectrum. The nickel vapor emissions grew weaker, replaced by a new line, pure iron, faint but distinct. It suggested that the object's outer layer was fusing, the metals consolidating under continuous exposure to sunlight and magnetism. The mirror skin was hardening, perhaps transforming into a permanent shield. If that were true, it meant 3I Atlas had reached the final stage of its metamorphosis, stability. By midsummer, the orbital data confirmed it. The object's inclination had matched the ecliptic almost perfectly. From our vantage point, it now glided along the same cosmic sheet that carried every planet and asteroid in our solar system. It had joined the plane of order, leaving behind the chaos from which it came. There was something deeply human in that image, wasn't there? A wanderer from the void, drawn not by force, but by resonance, finding harmony among the celestial family it had never known. Perhaps that's why we couldn't stop watching. Because in its motion, we saw our own yearning to belong. And yet, beneath the beauty, there was unease. The object's acceleration hadn't ceased. It continued to adjust its position, always aligning itself with the gravitational centers of nearby planets, as if responding to their presence. When it passed near Earth's orbit, the telemetry shifted once more. The non-gravitational force reversed direction, slowing its approach, as though it were preparing for something, for observation perhaps, or for rest. We began to lose sleep. The idea of an interstellar body adjusting its orbit to match ours was almost unbearable to contemplate. It felt too intentional, too directed. Still, the data remained precise, undeniable. 3. Atlas was no longer a comet in transit. It was a participant in the dance of planets. The night it crossed the Earth's orbital path, the world held its breath again. Every telescope turned to the same point in the sky. The light shimmered once, twice, then steadied into a calm, unwavering glow. Its motion slowed, its acceleration balanced, as though it had found equilibrium at last. And yet, even in that stillness, we sensed that the story wasn't over. Something deeper was beginning to unfold, not in its orbit, but in its nature. Because the next readings, those that came from the high-resolution spectrometers, revealed a signature no one could have predicted. Elements too pure, too structured, too uniform to belong to any known natural process. It was as if the surface of 3I Atlas had become something new, a material refined beyond nature itself, carrying a message not in language, but in order. And as we peered closer, analyzing every photon that reached us, we began to understand that whatever we were witnessing was not simply a phenomenon of motion. It was the unveiling of a pattern, a hidden intelligence etched into matter, waiting for the light of a star to make itself known. By late autumn of 2025, the tone of the scientific world had changed. What had begun as curiosity had grown into quiet division. Every observatory had its own version of 3I Atlas. Now each dataset calibrated slightly differently, each conclusion bending gently toward its author's conviction. Some insisted it was a natural phenomenon pushed to the extreme. Others, with careful restraint, hinted that it might be something more. The object itself hadn't changed. It was still gliding serenely along the ecliptic, reflecting sunlight in that impossible, liquid rhythm, but the way we looked at it had fractured. And perhaps that's inevitable. When the universe whispers something we cannot explain, our instinct is not unity, it's defense. The first cracks appeared in the journals. Papers were retracted, then republished, then rewritten in language so cautious it bordered on poetry. Terms like non-gravitational influence and thermochemical regulation began to replace words like control or system. The phrase narrative alignment started circulating in research circles, a quiet acknowledgement that certain interpretations were being massaged, softened, curated. It wasn't a conspiracy, not really. It was fear disguised as prudence. Because what if we were wrong? What if, for the first time in history, science had stumbled upon something that didn't fit within its own vocabulary? You see, science is brave, but it is also careful. It is an art of doubt. And yet, 3I Atlas seemed to mock our carefulness. Every new measurement deepened the contradiction. The object's reflectivity now fluctuated in quantized steps, tiny discrete jumps that defied the continuous behavior of natural materials. The spectral signatures grew cleaner, not dirtier, as it interacted with the solar wind. Normally, exposure erodes structure. Here, it refined it. The surface chemistry was evolving toward order, not decay. A few of us, late at night, began to speak less like scientists and more like philosophers. What if matter itself can learn? Someone whispered. What if the laws we think are fixed can, under certain conditions, begin to self-correct? The idea was beautiful and terrifying. If true, it meant that intelligence wasn't an accident, it was a property, a tendency of the cosmos to refine itself. But not everyone saw beauty. Many saw danger. Funding boards began to cut ties with research teams that used speculative language. Data sharing channels went dark. Some observatories reported being asked to pause publication until results could be contextualized. Others claimed their archives had been partially locked, files marked under review. It felt less like censorship and more like containment, a collective effort to stop the story from spinning out of control, and yet it was already too late. The story had escaped into the public imagination. 3i Atlas had become a symbol. Some called it the messenger, others the machine of God, and some, more poetically, the mirror of creation. Every culture projected its own myth upon it, but for those of us closest to the data, it wasn't myth that frightened us. It was precision. Dr. Eames, usually calm and skeptical, became withdrawn. "It's too clean," he said once, staring at the spectral readouts. "Natural systems don't do clean." He was right. The ratios of metals, the stability of rotation, the alignment of trajectory, they were all too perfect, too balanced. Perfection, in the universe, is rare. When we see it, it usually means we're missing something. Meanwhile, new telemetry arrived from deep space probes positioned along the ecliptic. They detected microfluctuations in the object's surrounding plasma field, tiny oscillations that appeared to respond to solar cycles. The field wasn't random, it was structured, modulating with frequencies that mirrored those of solar radiation. It was as if 3i Atlas was listening to the sun, matching its pulse, learning its rhythm. The argument within the community began to crystallize into three camps. The first, the conservative group, clung to the comfort of physics. They called it a natural extremity, a comet composed of rare materials behaving at the edge of known conditions. To them, 3i Atlas was extraordinary, but not miraculous, a cosmic coincidence that teased the limits of our understanding. Nature, they said, is the best engineer. The second camp, smaller but louder, entertained the possibility of design. They didn't claim alien intent or science, fiction. Their argument was subtler. Perhaps this was a relic, a fragment of something once engineered, a vessel, or probe, or artifact long since abandoned, now drifting between stars. To them, 3i Atlas was not alive, but remembered how to be. It had become the fossil of technology, still functioning because it was built to endure. The third camp, perhaps the most radical, saw something entirely new. To them, the object wasn't natural or artificial. It was the first known manifestation of a new kind of physics, where matter and energy interact not through static laws, but through feedback. It's neither life nor machine, they said, but the next layer between them, a phenomenon that uses nature as its language. And that, I suppose, is where I stood. Not with certainty, but with wonder, because the truth, whatever it was, seemed to lie somewhere between all three. The crisis came when the datasets began to diverge. Independent observatories reported shifts in light frequency that others couldn't confirm. Some saw a faint modulation, like a pattern riding on the light wave itself. A few claimed to detect binary pulses encoded within the reflection, though others dismissed it as instrumental noise. The disagreement wasn't just academic, it became existential. If those pulses were real, then 3i Atlas wasn't just responding to the Sunday, it was communicating, however faintly, through the medium of light. That idea split the field apart. Institutions withdrew, papers were labelled non-verifiable, and those who persisted found themselves quietly sidelined. I remember walking into the lab one morning to find our access to certain databases restricted. It was never announced, but we all felt it, the slow tightening of what could be said. And yet, the data kept arriving, indifferent to politics. The object continued its serene passage along the ecliptic, its light unwavering, its geometry precise. Even the skeptics began to admit that its motion defied every model of natural cometry dynamics. It moved as if aware of its own stability, conserving energy with a kind of cosmic grace. I suppose that's what fascinates me most. Not whether it was built or born, but how it seemed to choose balance. In a universe that tends toward entropy, here was something that tended toward harmony. It was, in a sense, the universe remembering itself. When I think back to those long nights, staring at the glowing waveforms, I often recall a line from one of my lectures. Science doesn't fear the unknown, it fears the silence that follows when we stop asking. Perhaps that's what 3i Atlas was trying to teach us, not to answer, but to keep listening. And that, well, that's the strange gift of anomalies. They remind us that certainty is not the same as understanding. They force us to look again, to imagine that the fabric of reality might be richer than we dare to believe. By the end of the year, the object had passed, beyond the orbit of Mars, still descending gently toward the solar plane. It left behind a trail of particles unlike any cometary dust we'd seen before, microscopic spheres of metal alloy, uniform in composition, smooth as if forged. Samples collected by solar interceptors showed traces of crystalline nickel bonded with carbon in a lattice structure. It wasn't just metal, it was material with order, perhaps even purpose. And so the question returned, more urgent than ever. Was it chance? Was it design? Or had we stumbled upon a third category matter behaving as mind, the universe exploring itself through pattern? Whatever the truth, 3i Atlas had done something no equation could. It had humbled us. It had reminded us that knowledge is not the end of wonder, but the beginning of it. As the light from the object faded into the dark beyond Mars, I stood outside one evening, looking at the faint shimmer that marked its path. The sky was clear, the air still, and I thought perhaps this is how it always was. Perhaps the universe has been speaking to us all along, and we've only just learned how to hear. And somewhere, deep in that quiet, I sensed that 3i Atlas hadn't left us at all. Its story was still unfolding, not in space, but within us. For the next time our instruments would detect its whisper, the signal would come not from its motion, but from its chemistry, a final, delicate message hidden in the very atoms it had left behind, waiting for us to decode what the universe had been trying to say since the beginning. The night sky had long since fallen silent, and yet, in the wake of 3i Atlas, that silence no longer felt empty. It felt alive, thick with meaning, humming with the faint echo of something that had once passed through sunlight and left behind a trace too intricate to forget. For months, our instruments had gone still, their data streams complete, their questions unresolved. But even as the last fragments of telemetry faded, the debate remained, circling like a planet around its own uncertainty. You see, in science, closure is a myth. Every discovery, every anomaly, opens more doors than it closes. And 3i Atlas, whatever it truly was, had opened the widest door of all. It asked us to decide whether the universe is a machine of accident or of design, and whether, perhaps, the difference between the two was never as clear as we thought. When I look back to that first light curve, the pulse that started it all, I realize how small the question seemed then. Just a rhythm, repeating, just a pattern of brightness, where there should have been chaos. But from that heartbeat of light, an entire philosophy unfolded. Each layer we peeled away, heat, chemistry, motion, time, brought us closer not to an answer, but to a kind of humility. Because if it was natural, then nature has depths we've barely imagined. A rock that could modulate its own temperature, balance its spin, refine its surface, and guide its path across the gravity of worlds that's no mere accident. It would mean the cosmos itself is a kind of intelligence, a self-organizing system that learns to preserve beauty through balance. It would mean that life, as we define it, is not unique to biology. It is a principle written into the laws of energy and motion. And if it was artificial, if somewhere in its metallic core there lingered intention, then we are not alone in our curiosity. Perhaps, long ago, another civilization looked out upon their own sky and wondered if they were alone. Perhaps they built something to ask the question for them. A messenger that would outlast memory, crossing between stars not as a ship of conquest, but as a seed of inquiry. And perhaps 3i Atlas was that seed still functioning, still adapting, still learning how to survive in the light of new suns. I sometimes imagine them, the unknown makers, designing a body so perfect that it could imitate nature itself, a structure that doesn't need maintenance because it repairs itself, that doesn't need fuel because it sails on the breath of stars, a body that could outlive its purpose and yet keep moving because motion is what it was born for. If that's true, then perhaps the moment we first detected its pulse was not the moment it found us, but the moment it remembered what it was meant to do. Still, I wonder if the distinction even matters, because what 3i Atlas truly did was blur that very line, the one between the living and the inert, between chance and choice. It forced us to see the possibility that intelligence and nature are not opposites, but partners, That what we call design might simply be the universe learning to recognize itself. There's a quiet irony in that thought. We sent our instruments to measure light, to quantify it, to strip it of mystery, and yet, in doing so, we found wonder again. We learned that light isn't just radiation. It's memory. It's conversation. Each photon bouncing from 3 Atlas carried with it a story, told in a dialect of chemistry and geometry, of rhythm and resonance. And if we were careful enough to listen, it began to sound almost like language. I suppose that's the real gift it left us, not knowledge, but perspective. The realization that our universe is not silent, it's speaking constantly. We just need to learn its grammar. Every orbit, every pulse, every fluctuation in heat and light is part of a grand syntax, one that connects atoms to galaxies, comets to consciousness. 3 Atlas was one sentence in that cosmic poem, a fragment, perhaps, but one that hinted at meaning beyond comprehension. And maybe that's enough, because meaning doesn't always come from certainty. Sometimes it comes from the act of wondering. I think often of those 2 hours, the lost interval when every telescope went dark, when 3 Atlas disappeared into silence and returned, transformed. We called it a blackout, a gap in data. But perhaps it was something else. Perhaps it was a kind of pause, a breath between notes. Because everything that followed seemed to emerge from that silence. New structure, new chemistry, new purpose. As if it had gone somewhere beyond our reach and come back knowing more. That thought used to frighten me. Now it feels comforting. The idea that learning, even for something as alien as 3 Atlas, might require stillness. That knowledge is born not from noise, but from the spaces between. And so, as it drifts now along the ecliptic, quiet, steady, indifferent, I find myself wondering what it has become. Maybe it's dormant, waiting for the next cycle of sunlight to wake it. Maybe it's listening, mapping the frequencies of planets and their magnetic fields, weaving itself into the song of the solar system. Or maybe it's simply continuing what it's always done, traveling, adapting, seeking the balance that allows it to endure. You see, we often speak of the universe as if it's indifferent, as if it doesn't care whether we understand it. But I'm not so sure. Perhaps comprehension itself is a kind of participation, a way for the cosmos to become aware of its own existence through us. If that's true, then 3 Atlas wasn't an intruder at all. It was a mirror, reminding us of who we are in the grand pattern of things, observers through whom the universe observes itself. And maybe that's why its rhythm felt so familiar. Because, in a way, it was our own reflection, our own heartbeat echoed in light years of distance. One night, not long after the last data stream ended, I went back through the old recordings, the very first sequence, from the night it was discovered. 3 pulses of light, evenly spaced, clean and steady. I played the audio translation, the pulse converted into sound, and listened in the dark. It reminded me of a breath, inhale, exhale, pause, and I thought, well, perhaps that's all this was. The universe breathing. If it was only a comet, then nature is far cleverer than we give her credit for. To shape matter into rhythm, to carve precision from chaos, to teach us awe through the simplest flicker of light that is artistry beyond design. But if it was something made, something sent, then the implication is even greater, because that would mean we are not alone in seeking meaning among the stars. Somewhere, across the distances, others once looked into their own darkness and wondered too. Either way, it has changed us. Since 3 Atlas, our instruments have become more sensitive, our models more daring, but more than that, our imaginations have expanded. We now speak of adaptive matter, of self-organizing systems, of living physics. And while the equations are still uncertain, the sentiment beneath them feels timeless, that the universe is alive in its own quiet way. When students ask me what I think it was, I tell them the truth. I don't know. I don't think we're supposed to, because mystery is not a flaw in science, it's the fuel that keeps it moving. What matters isn't the label we give it, but the space it opened in our minds. 3 Atlas reminded us that the unknown is not something to fear, but something to approach with reverence. And perhaps that's the real story here. Not the object itself, but what it awoke in us, the sense that we are participants in something vast and interconnected, a story still being written in starlight. When I imagine the object now, far from the sun, drifting outward along its chosen plane, I picture it gleaming, faintly its mirrored surface reflecting not chaos, but order, not silence, but harmony. Maybe that's all it ever wanted, to align itself with the cosmic rhythm, to become part of the great motion that binds planets, stars, and time. And if we learned anything from its passage, it's this: that harmony is not perfection, it's adaptation, it's survival through understanding. It's the willingness to listen, even when the song seems strange. So, when I'm asked what Three-Eye Atlas truly was, I sometimes smile and say, it was a question. Because in the end, that's what the universe gives us, not answers, but questions so beautiful they make us reach beyond ourselves. And maybe, just maybe, that's the point. If it was only stone, then nature is a sculptor of unimaginable grace. But if it was made, if it was shaped by hands, we'll never know, then we are not the first to listen to the music of the stars. Either way, that night, as sunlight scattered across its polished skin, the universe spoke, not in words, but in rhythm. And if you listen closely, really listen, you can still hear it. The faint pulse of Three-Eye Atlas echoing through the quiet, reminding us that even in the vastness of space, there is intention in the dance of light. And that perhaps, in some distant future, when another world turns its telescopes toward our sun, they too will see a rhythm and wonder, as we did, what it means when the universe begins to keep time,